Welcome back to the tutorials on Ansys Workbench. So in today's session we will solve one more problem on truss. So this is the problem statement. Determine the total deformation, reaction forces and stress for the truss system shown below. Truss elements are made of structural steel of Young's modulus 200 GPa and Poisson ratio 0.3. Cross-sectional area of each element is 1 meter square and is of square cross-section. The length of each segment is 50 meter. So this is the truss given in the figure. So each truss bar is made of structural steel and its length is 50 meters and it is having a square cross section. Area is given as 1 meter square and here it is completely fixed and here it is having a roller support. So this vertex and this vertex is subjected to a load of 1000 Newton. So we will solve this problem by using Ansys Workbench. Static structural. So I will rename this as truss 3. So edit the engineering data as it is structural steel. Just check for Young's modulus. Yes, Young's modulus in MPa or in GPa directly. So it is 200 GPa and Poisson ratio is 0.3. Correct. So close this. Next, geometry, right click, new design modeler geometry. Select XY plane, look at face, change the units to meters. Now I am going to create this geometry first. So go for sketching, directly select polyline. So I will start from here, one line here, so I will make it as close end. Next again here to here. So just press, so just delete this, go for modify, cut, so cut this, so cut, okay. So next go for dimensions, general, okay. So select all the lines. This is not required. Cancel. Okay, cancel. So now change this dimensions to 50. This is also 50. 50, 50 and 50. So click on generate. So basically we have created the sketches. So it is just a sketches. So from the sketches I want to modify it as a lines. So this is a sketch and this is a sketch and this is a sketch. I want to convert this sketch into a lines for 1D elements. So to do that, go for concept, lines from sketches. So you select all the lines, press Ctrl and select all the lines and you can click apply. Finally click on generate. So now lines has been created. So to assign the cross section, first go for concept, cross section, rectangular cross section. So this is 1 meter and this is 1 meter. So just click on generate. So now you can click on this part body and line body assign the cross section as rectangle 1. Click on generate. So now you can minimize this and go back to the workbench, double click on model, so now cross section has been already assigned. If you want, you can check this geometry. Next, materials, we have only one material, that is structural steel, and it is already assigned. So directly go for mesh, right click and generate mesh. So meshing is also done. Next, directly go for static structural, right click, insert, fixed support. So this vertex, select this vertex and click apply. And again static structural, right click, insert, displacement. So here it is a roller support. So click on this, apply. So X component is free, so it can move in the X direction freely. So in the Y you make it as constant, and Z make it as constant. So go for static structural, right click, insert, force. So now I want to apply force on this vertex, press Ctrl and select this vertex, apply, change vector to components. So here you can see the compass, it is in Y direction, so -1000, -1000. So whenever I click on this force, here you can see two vertex, so vertex 1 and vertex 2 as selected. The load is 1000 Newton. So now go for solution, right click, insert, deformation, total deformation you can select, and if you want you can also select directional. Next, insert, probe, force reaction. So I want at the fixed supports. Next, for stress I am going to insert beam tool. So now right click on solution and solve. So wait for some time. Now your solution is done. So you can click on total deformation. So this is the total deformation, units is in mm. You can change this to meter. So this is the total deformation, so units is in meters. And this is the directional deformation, so this is in meters. If you want, you can change this to mm or meters. So next, force reaction, you can see the force reaction at this vertex as it is the fixed end. So this is the force reaction. Next, expand this beam tool and you can click on the stress. So this is the direct stress. So this is the solution for the given problem. Next, if you want to generate the report for this, you can go to home and here you can go for report preview. So click on report preview, so it will generate the report for you. Suppose if you want only the answers, like I want only the total deformation answers, you can also play the animation like this. Okay, so this is the animation. If you want only the picture of this along with this contour graphs, so you can go for result, and you can go for image to file. So click OK. So on the desktop I will save this as Truss 3. Save. Next, you can go for direct stress and again click on images and image to file. OK. So Truss 3 stress. So individually you need to save. So now you can go back and check. So this is the image, it will be saved. So thank you, see you in the next video.